still alive until now. So he's discovered about the back propagation algorithm on how the weightage been updated. He come up with a new equation how the weightage is updated in this algorithm. Okay. So still the same. The backpropagation algorithm same as the other algorithm. So just the difference is the architecture also same. Just the difference is how the weightage is updated is little bit complicated. Not very complicated, but there is many stages involved when we want to update the weightage by using backpropagation training algorithm. Okay. We also call this algorithm as a feed-forward neural network. So means feed-forward is just we put in the data to the input, and then we update the weightage, and then the data will come out the output, and then we'll compare to the target, and then we can find the accuracy of the model. Okay, and this algorithm also can be applied to the multi-layer net, not only single layer. We can also apply this algorithm to a multi-layer. Multi-layer means we have two hidden layer. Okay, like this here. So in HapNet or perceptron, the example we have only single layer means you have input, and then you have the weightage, and then you have output. But for backpropagation, we can also apply as a two-layer architecture. So we have here a hidden layer. We call it a hidden layer here. Okay, so we have a input layer, hidden layer, and then the output layer. And we have still a bias here. Okay, so this is how the backpropagation algorithms architecture look like. So another term of this type of algorithm we can call it a multi-layer perceptron, MLP, or feed-forward neural network, all same. Okay, and the architecture we have a input layer, we have an output layer, and we have a hidden layer. Like just now I show you in the figure. Okay, and it also have a bias at the output layer. Okay, also have a bias at the output layer, and the type of input still the same. Either we need to have a binary type number or bipolar type number. If binary is 0 1, if bipolar is -1 1. So that means any data, whatever data you have, image data, brain signal, like my research I doing brain signal data, or voice data, whatever data we have, first the data is in the form of its range, but in order to train the data in this type of neural network, first we need to convert all this type of data into either binary type or bipolar type. Binary means the data is 0 1 0 1, or bipolar type means the data is between -1 +1. Okay, and it also have activation function same as the perceptron, and we have so many function as a activation function. And the things that the idea come out from backpropagation algorithm is it using a delta rule in order to update the weightage. Okay. So what is different between perceptron, HAP, and backpropagation? The difference is the if perceptron we train we update the weightage until the weightage is same as the weightage before. In HAPnet, the condition is we just update if we have two input, we just update the weightage for two inputs. But for backpropagation, we update the weightage until the error between the target and also the output is small. Means whatever error, delta error, let's say it is defined by us. We want to model the neural network, so we need to define the error to stop the network updated the weightage. So how the network is stopped with update the weightage is depend on the error of the delta, which is the difference between the input and the output and also the target. So let's say you get when you training the data and then you get the output 0.9, let's say 0.5, and the target is equal to 1, so you have a difference 0.5. If we say the network need to be stopped until the error reach 0.05, that means now we have 0.5 is not reach 0.05, then it will update again the weightage until it reach 0.05, then the training will be stopped and we will have a final weightage. So that is the difference between backpropagation compared with the simple algorithm that we have learned, which is perceptron, and also the HAPnet. Okay. So this is the training algorithm for backpropagation. Same. First, the weightage is initialized. This is normally is random. The computer will make it random to get the initial weightage value, and then it will put the input into the layer, and then at hidden layer we will calculate the Z value, and then at the output value we will calculate the output value Y, and then when we can get the output value Y, then we calculate the difference between target and also the output here. If the target and the output, if the delta K we get, let's say we set the training will stop until data is equal to 0.005. So the training process will running if it don't reach 0.005 until the delta K equal to 0.005, then the training process will stop, and then we will get the final weightage value, and that weightage value we will use to test our network whether it can get the good accuracy or not. Okay, so the difference is this time how we want to stop the update the weightage is based on the delta value, which is the difference between the target and the output. Whereas for the yesterday, the simple algorithm, perceptron and HAP, perceptron we update the weightage until the weightage is same as the weightage before, or for HAPnet we don't compare to anything, we just update the weightage until all the input is being processed. So that's the difference between these three algorithms. Okay. So this is how this is the equation of how we update the weightage. Okay. So W new is equal to W old plus delta W, where delta W is given as this. So we have alpha, delta K, and Z value. We will see the example after this, how the process of back propagations running. Okay. And of course, in each of the neural network, we have also activation function, and the activation function can be any activation function. So normally for my case, when I want to model the neural network for my data, I always use I use a brain signal data. When I want to model the neural network, I always do the try and error. Sometimes this activation function can give me the good accuracy of my network. Sometimes different activation function can give low accuracy for my model neural network. So it depends also on activation function and depend also on your data. Okay. So there is no wrong, no right. It depends on your data. Okay. So the common activation function that used for backpropagation is we call it binary. If the data we convert it into binary, so we always use a binary sigmoid. If it's a bipolar data, we always use a bipolar sigmoidal activation function. Okay. So this is just want to show you how the learning rules is derived. So this one you can see by yourself, but we just want to use the final equation here in order to update the weightage. So this is just the derivation to show you how we get this equation in the process to update the weightage here. Okay. So now we got the weightage updates here, the equation. And for initialize the weightage, as I said before, normally we get the initial weightage value by random number. Okay, by random number. So we random initialize the weightage value by it is given by the computer when we set, and then the computer will give the random number of the initialized weightage value, and then after that, starting from there, then we train the network, and the weightage value will be updated until the delta value of delta is small enough in order the network to be stopped. Okay. And it's also say here the weightage sometimes is not too large and not too small. So actually it's depend on also on data, and also depend on the activation function. So it is based on that parameter. Okay. Sometimes we use also we call it a Newgen withdraw initialization. This is one of the method on how we want to initialize on our weightage value. Okay, there is a lot of initialize method that been introduced by a researcher, because researcher want to come up with the method in order to give the initialize process faster. Okay, if you have a so big data, so sometimes when we use this kind of one type of initialize method, sometimes it can be so slow in order to update the weightage. So that's why many researchers have come up with a new algorithm in order to initialize the weightage. So the learning process on updating the weightage will be faster. Okay. But normally we just use whatever we have in MATLAB. It's already given. We just take the algorithm that in MATLAB, available in MATLAB, and then we use it. And then we try an error whether then we want to see whether it is fit for our data or not. Okay. So I want to show you the example on how we update the weightage of this type of network. Okay, so this is the example here. Consider the feed-forward network shown in figure. So this is the feed-forward network here. We have 4 input, and then we have hidden layer here, and then we have 1 output layer here. Okay, and the question asks you to train we need to train the network using the backpropagation algorithm. So this one, the question not ask us to train until the delta is small, but he just want us to show how the weightage is updated. So he say train the network using backpropagation algorithm only for 1 epoch. Epoch means the 1 cycle of updating the weightage. If we say 5 epoch, so that means we update the weightage 5 times. First, second update, third update, fourth update, and then 5 update. So finish 5 epoch. 1 epoch means one cycle. Okay. And the question say the input training pattern is given here, 1, 1, 1, 1. And the target also is given, -1. So if you look at here, the input is 1, 1, 1, the target is -1. So we know already it use what? Bipolar or binary, it use a bipolar data. Okay, because the target is -1, so that means we have only 1 output layer here. So maybe if 1 output layer, the possibility of data is either -1 and 1. So it is in bipolar data. So the question asks us to determine the new wave. That means to show how we update the weightage using the backpropagation algorithm. Okay, and assume the learning rate equal to 0.5. Assume the hidden and output layer neuron are activated by using bipolar. So this is the activation function bipolar sigmoid activation function. So how we can start? So this is how the architecture of the backpropagation algorithm network. So because we have the input data 1, 1, 1, 1, so that's why we have 4 input here. 1, 2, 3, 4. And then we have hidden layer 2, and then the output either is -1 or 1, so that's why we only have 1 output layer here. Okay, and if you see here, like I said before, sometimes how we can stop the network is depend on the data will be different between target and output. So you see here, this is come out the output Y. When output Y come out, and then we compare with the target T, and then we can get the value of error E here. So if we say that we want to make this network, to train the network until and the network train is stopped until E is equal to 0.005. So when we get value of Y, the target minus Y, and then we see what is the value. If we don't get 0.005, then the process of updating the weightage will be go on until the E1 is got 0.005. But for this question, it's already mentioned that we only want to update the weightage in one approach. That means we don't care whatever value of E, but we just update the weightage in one approach. Okay. So the initial value of weightage is given here. So we have input layer, hidden layer, output layer. So that means here we have two uh, two different weightage. One is the weightage between the input layer and hidden layer. So we name it as V. So it's V11 is for this link, V12, V21, V22, V31, V32, V41, V42. So this is given the value of weightage for V, and then the weightage between the hidden layer and the output layer we given as W. So W11 and W21. So this is the value of weightage for W. Okay, so this is V11, V12, V21, V22, V31, V32, 0.7, V41, minus 0.5, V42. So our task is to update the weightage only one approach. How to do this? Starting from here. First, we calculate the Z in value here. So what is the in value is X, the input times the weightage. Okay, so Z in total Z in value is this plus this plus this, V11 times X1 plus V21 plus X2 plus V31 plus X3 plus V41 plus times X4. Okay, so we get Z in 1. And then we need to find the output from Z1, which is given as Z1 is equal to 2 over 1 plus E minus Z in 1 minus 1. This is the formula for bipolar sigmoid activation function. Okay, so we get Z1 is equal to 0.05. Okay, so first we need to find the output of Z1, and then we calculate the output of Z2 here. Okay, so it's still the same operation. But this time for Z2 here, so X1 times V12, X2 times V22, X3 times V32, X4 times V42, sum up, and then again calculate the Z2 here, the output of hidden layer here, and then we got 0.1974. Okay, this only we got until here, not yet until the output. Now it's only until the hidden layer. Okay, and then from hidden layer, then we want to calculate the output value from the output layer Y1. So again, same concept, same method. So we have weightage time the output here, the input from Z1 time the weightage W11 plus W21 time Z2. So we have Y in 1, okay, the input into the output layer here. Okay, so Y1 is equal to 1 plus E minus Y in 1, same as here. This one minus Z in because we use the Z in. So this one, because this is Y in, so we use the minus Y in. Okay, so we got Y1 is equal to minus 0.0665. And then we need to calculate the error. Okay, Y1, T1 minus Y1. So we all, the question already say the target is minus 1. So minus 1 minus 0.0665. So we got E1 is minus 0.9339335. Okay. And then we need to calculate the delta value. Okay. Because now the thing is we don't update yet the weightage. So in order to update the weightage, we need the delta value. So this delta value, delta K1, we want to update the weightage for W and W21. This delta J and delta J2, we want to update the weightage for V. Okay, so that's why we need this value, and this value. So it's given as delta is equal to the error times the differentiation of the Y in 1. For delta J, same, equal to delta J, delta K1 times W11 times this formula times the differentiation of Z in 1. Okay, so this one is times the differentiation of Y in 1. Okay, so first we need to calculate this. Without this, we cannot update the weightage of W. Without delta J1 and J2, we cannot update the weightage of V1 and V2. So first we want to update the weightage of W11, W21. So we need to calculate the delta K1. It's given as this formula. Then we got the value of delta K1 minus 0.4647 here. Then using this value, then we update this weightage. So W11 new, again using the formula given in algorithm, W all plus alpha learning rate times delta K1, this value, times Z1, this value. So we got new weightage value for W11, new weightage value for W21. So now we already update the weightage here and the weightage here. Now we want to update the weightage here. So we need to have this value, delta J1 and delta J2. So delta J1 here equal to delta K times W11 times 0.5 times 1 minus Z1 times 1 plus Z1. So if you see here, for delta J1, you need all the value before the delta J1. So we need this new value, this value, and this value that we have calculated before. Then we can calculate. Without this value, we cannot calculate the value of delta J1. Same also for delta J2. We need the value of delta K1, Z2, W21, the new weightage that been updated before W21, then we can have the value of delta J2. Then when we got the delta J1 and delta J2, then now we can update all the weightage here. 1, 2, 3, 4, 5, 6, 7, 8. Same equation, alpha learning rate times the delta times the input. Then we can get the new weightage here. So this is how the backpropagation algorithm, how the process of update the weightage is a little bit complicated compared to the perceptron algorithm and also the the HAPNet algorithm. So if you look at here, why we call it a backpropagation, because if you look at the process on updating the weightage, is something like we go back when we get the value of output, and then we go back in order to update the weightage. That's why we call it a backpropagate algorithm. So when we got y1, we got the different value of the target and y1. Then first we backward calculate calculate delta, and then update w, and then back calculate this, and then we can barulah kita boleh we can update the v. It's something like we back propagate. First, the data go in feed forward. In order to update the weightage is back propagate. That's why we call this algorithm as a back propagation algorithm. The process of how we update the weightage is in the backward. Okay, we update the weightage in a backward direction. So that's why this algorithm we call it a back propagate algorithm. Okay. So the question only asks us to calculate, get the new weightage value only after one approach. So that means first we put the input data, calculate the weightage, calculate the value until we get the value output and compare with the target, and then update back the new weightage value with the back propagate, then finish one approach. So if the question say 2 approach, that means you need to make it 2 times. First, calculate this, update the weightage, 1 approach. Again, calculate this, calculate back the delta value, update the weightage, and then finish second approach. So it's a bit complicated. But for research, this is all done by the MATLAB. Okay, I just want to show how the process of this algorithm by to update the weightage. In MATLAB, we just put the data, put the coding, then play up, and then we come up with the answers. That's all. Okay, so this is actually what the process is actually been done in backpropagation algorithm. Okay, and normally we don't stop the training process for this neural network model based on approach. Normally we set the parameter E, as I said before, until we get very small error between target and output y1, then the training is stopped. Then we test it. Either our model can classify with the high accuracy, maybe 100 accuracy, if we have different type of data here. Okay, so this is how the backpropagation algorithm works. So if you don't know, or if you want to refer back how it works, so you can backpropagate. this lecture note. Is this is how like the similar how the process of updating the weightage go forward and then go backward to update the weightage. So any question on this type of algorithm? I will give this lecture note in order for you to back propagate back all the notes to make you more understand. After this, I will give the lecture note. So for my research, still using this type of algorithm because normally it can give higher accuracy for my neural network model. Even though we have many type of machine learning algorithm like support vector machine, SVM, what else we have, the new one, deep learning and all that. Sometimes I'm still using the backpropagation algorithm because it can give a better result. But for perceptron and HAPNet, that is very old one, is difficult for if you want to classify the big data or the complicated data. So it's very difficult to get the good accuracy for your model if you use the HAPNet or the perceptron. So, any question?
No, doctor.
So, if don't have any question, I think you maybe want to look at back all the this lecture note first. So I will send to you the lecture note and then please study, and any question you can ask me after holiday. So the task that I give you yesterday, we can discuss it after holiday during face-to-face lecture. So if you don't have any question, I think I stop here. So happy holiday, selamat hari raya, maaf zahir batin. Kalau ada masa, jemputlah datang rumah saya time raya. Bukan time raya, lepas raya lah. Okay. Okay, Assalamualaikum and bye-bye.
Thank you, doctor.
Thank you, sir.
Thank you, doctor.
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 Thank you, doctor.